Good afternoon, ladies and gentlemen, and I congratulate you on your endurance. It's way past my bedtime. But here we are, futuristic London, God help us. My background is design and engineering, and for over 40 years I've been in plastics thermoforming. Started protective packaging systems around 10 years ago. We designed, developed and patented a system which has now got global patents. But around 25 years ago, in manufacturing with a thermoforming company, we produced plastics packaging predominantly, and it was about that stage when we started to use terminology like reusable, recyclable, using recycled materials, and that became part of our sales and marketing effort. And sure enough, there was some interest gained from some fairly major retailers, and that interest lasted for as long as to the point we told them that it was a few bob more. And so consequently, this is an uphill struggle that in industry we've had. You have to pay for recyclability and reusability, and some people just aren't prepared to do that. However, a couple of years ago, I saw an abstract from Janis Potternick, and I was encouraged. I thought, here we go. This is good news. And then I saw that he left his post, and along came Carmenu Vela, and lo and behold, eureka! We seem to have some traction and some continuity. But the idea of reusable, recyclable, and closed-loop manufacturing was something that interested us, and we were trying to develop and penetrate markets. And I went online about 10 years ago to have a look at some sort of format, something that would show what we're trying to pursue. And frankly, there was simply nothing online in terms of charts. So we cobbled together our own chart, and we headed off over to Dell in Austin, Texas, and we showed them this idea of a hypothetical company, Ward, manufacturing computers, laptops. Here's our packaging concept, and the idea it would get global distribution through our licensees, and then it would be returned back to distribution centres where the low-G packs would be sorted, and the good ones would actually return back to the manufacturing plant. Those that were damaged would then go through to baling, extrusion, thermoforming, and back into the chain. And well, it worked. I mean, we got a small contract, and we produced some parts for Dell in Ireland. So that was very good news. The point is that I went online a couple of days back just to have a look to see if there's some charts, and frankly there's more charts that you can shake a stick at. So there is traction. Now I think we should be encouraged that more and more people are starting to look at closed loop manufacturing, this circular economy, and from our perspective we think that this is pretty well a good chart where you've got both the technical aspect and the bioecological aspect. But for simplicity's sake, that we're talking about raw materials being produced into product, consumers recycling the product, and we've got this closed loop. So that's what we're after. I want to show you just a quick film, a bit of footage, because there's a bit of inspiration here as far as us as a company were concerned. Doesn't seem like we've got any sound. Hey. Okay, a pretty inspirational piece of packaging there. You can just think about the cost of quality on that one. But there is an issue with that. I don't know if anybody was counting, but I figure there's about 10 pieces of waste that's just thrown off into space. So there we are, point in question. But this is our protective packaging system. Our version of Curiosity. And as you see, this is a 1.2 metre drop test with a pretty heavy and highly sensitive product. And the low G system, we believe, is a system that sets itself apart from others. The issue is that technology is on an exponential curve. We all know that. We buy something today and it's out of date tomorrow. You can see over a fairly short period of time the improvements in technology. And that and the advent of online ordering, its phenomenal rate of growth, means that the need for protective packaging is growing with it. These are the options, the traditional packaging, and each of them have their own issues. The origami, where it's spend an hour trying to assemble it and even longer trying to disassemble it. Bulky foams and expanded polystyrenes, chemical systems. We have inflatable systems, cut systems, expanded polystyrene. I'll not labour the point. But this was based on some work as some of the company members did on the first advanced composite BMW bumper beam system, which replaced aluminium. Lightweight, highly effective. But you can see here these packs are just bouncing. They deform and they revert. And the idea is that we want to try and do exactly what Curiosity did, get 360 degrees worth of impact absorption features. And how we do that is that we engineer into each design bellows, which run along the whole length of the pack, springs, and what we call buffers. On a typical pack, you can see that these interlocking, as you fold it up, these interlocking buffers protect from one side. The springs will be so positioned on a product where there's the lack of sensitivity. Anything that's got a sensitive area, we make sure we put airspace around it. And then finally, these buffers are the elements that stick proud. You can see there's a sort of cut line here. Stick proud and actually come in contact with any secondary packaging on the outside. So there's 3 levels of impact absorption designed into the inner, and therefore you don't have to worry too much about the outer. The outer carton now just becomes a sales message. But there is a degree of interaction. The benefits to the customer, well, I'll flick through this fairly quickly. For those that are involved in recycling, we all know that thermoform product nests and nests perfectly. So there's a high density of packaging. Because we've got rid of an awful lot of parts, there's a reduced bill of material, cost saving and all the admin to go with it, reduced pallets, generally our packs are smaller, reduced warehouses. We increase productivity. Each of these packs have a cavity tailored to the product that goes in there, and I'll show you some examples. We reduce transportation and, of course, greenhouse gases, reducing material costs, dirt and dust contamination, and packaging waste. So there's a big cost reduction. And, of course, if you've got a highly effective, high-performing pack, then everything's going through post now. We've sort of said about internet purchases. Then the reduction in failure is significant. All in all, it's the total cost of ownership. It is the total cost of ownership that's the critical factor and not the price. There's more things to actually consider. So as a company, which door do we knock on? Take your choice. I mean, Packaging engineering manager, well, we've got this state-of-the-art packaging system, high performing, easy to assemble, lower failure rate, and reduces packaging elements. Operations director, efficient kitting, reduction in labour, it increases productivity. You can automate it fairly well. Very clean, and we've had examples of going into clean room areas, especially in semiconductor businesses, where you're knee-deep in dust. It's unbelievable, just because of the cartons that they've used. Logistics, reduced bill of material, movements within the company, reduced storage. All these are factors that should be considered. Improve overall image. This was a product that we did for 3M, passport reader. Your option is that with your cut foams, or something that looks pretty effective and works extremely well. And purchasing. Again, reduced stock holding, reduced packaging materials, a potential to reuse the product. And at the end of the day, if you do actually lose out and the packaging is not reusable, it's collected, scrapped, and there will be a cash back for that company. Quality assurance, well, we've already spoken about this. Is a typical example of origami, where all the parts underneath this Ingenico card reader were just thrown. God knows what the failure rate was, but this was ours, where we had the reader in there and all the parts into separate cavities, and it folds up into a complete protective case. Materials, yeah, sustainability, yeah, curbside collection through the process of re-extrusion into the next low-G product. Pleased to say now that there is a green polyethylene coming from sugarcane, and you can mix this now. You can mix this with virgin, with LDP, HDP, blends, and it depends on the application and the degree of flexibility you want in the material and in the performing part as to what level of LDP you put in compared to HDP. And there's an awful lot of information to show that this is highly sustainable, fairly new on the market, but we are starting to use it. There is, unfortunately, of course, a cost premium. So where would we be using low-G? Typical applications. Anything along there we could pack and have packed. And just taking, for example, these docking stations. It amazes me at the number of different docking stations that you can actually purchase nowadays. But we would always start just with the product, and we design the product around the packaging around the product. And in terms of low-G systems, there is the full wrap here, there's a half wrap. Effectively, these two parts lock into the pack. So again, we've got this 360 degree of impact absorption. A Dell application with end caps. We've got the lid and base and corner caps, which are also patented now. That's our patent coverage. Our business model is that we select highly capable and technical thermoformers in all parts of the world, and we license them the product. Just a few examples, and I appreciate we haven't got much time, but just to show you the sort of thing. We were looking at Sky. They asked, could we get this product into the same pack? Yes, easily engineered. And that's the way it functions. We have male and female fitments here, so they stack on top of one another, taking them around the factory before being finally packed, nice and stable. Another example, you can see that this thing just has all its cavities tailored for the product, very easy to kit, and then into either a lightweight sleeve, lightweight carton, but we take substance out of the exterior packaging, so that's a cost saving as well. Some examples, this was for ST Micro, this was a 12-inch silicon wafer. They actually are held in injection moulded Fosby boxes. The weight was incredible, 13 kilos, and we just came up with the, oh, in fact, that's what we were competing against. This cut expanded polystyrene, which doesn't nest, so you have all the issues with that, and of course trying to get rid of expanded polystyrene, and simply drop it in, fold over, and there we are. 20% reduction in volume. I've thrown this in very quickly because this is something and it has led to a Dyson job. But that's what it was packed in. You know, origami, considerable size. We just did a line drawing, a line sketch showing how these things could be packed in two halves, brought together, and a 37% reduction in size. That equated on the volume of this particular product to a saving of 4.8 million just on transportation. Now, don't forget the shipping costs, the energy costs, petrol costs. There is a considerable saving to be had. Another example, exactly the same principles, and we've subsequently patented our system, which we call wine packs, but this is for a champagne bottle. And this is an interesting one because it's, first off, it's got an additional part, but we've designed it here so that when you've used the pack, you can actually lay it out, and you can, for the wine buffs, you can drop 4 bottles of wine in it, and then stack 4 bottles, stack 4 bottles, stack 4. So build it up that way. So there's an after use. Simply thinking about what can be used with, or after use of packaging, let's engineer some features into it. This is what we ended up with. And this is a product which is now on the market. Again, simply shows how quick and easy it is to pack and how it actually fits within the sleeve. So we can have interlocking, we can have protrusions, so even in a retail outlet, we can have these things stacked on top of one another, adding stability. And this is something we did for SEB, and typical sort of exercise. Can you produce packaging for our pressure cooker? Yes, we can. We come up with some options, the lid and base, the half wrap or the complete wrap. Yeah, that's all very good. You can see the product, got some handles, and we can stack within the retail outlet. Yeah, but actually what we want is the handles to sit proud. So back to the workshop, and we've just turned it through 90 degrees and got it featured that way. This is the passport reader with its CD disc, and lo and behold, that's how it features. Overall reduction 58%. ESD anti-static properties, yes, fine. There is a development, and this is something which Wim alluded to what seemed to be about 15 hours ago. We're now looking at Pulp as an option. Exactly the same features, exactly the same patent protection, but in Pulp. And the example that we were looking at, and this is the irony of it all. This is a particular project we looked at, some existing packaging, highly costly. We came along and showed some options here of a pulp option, thermoformed HDPE. And you can see where we stand on the price scale. It was the LCA produced by Deloitte. Moves on, we've got these options, and patently we are now becoming flavour of the month to win this business. Even when it came down to the sort of final figures, you had cardboard box, the low G pulp, the low G I'm green, which is that Braschem biochemical material, and the HDPE, which would be recycled, reusable, but recycled materials. So there we are. The problems are, of course, that the development costs for pulp is incredibly expensive. The rate isn't that good, and when we come down to the final prices, well, there we are. It's got to be one of these two. It's got to be one of these two. What do they go for? Pulp. Now, they go for pulp because it is consumer perception. You know, we've got all the figures. We understand that the energy for pulp is far greater than for thermoforming, the water usage, the steam. It's proven, and yet the consumer says, no, pulp is greener than plastic. Crazy. So there we are. That's how this particular product ended up. Is now in the market. And I was talking to a couple of guys today, and I'll just say this briefly. The crazy thing was talking to the company, Liberty Global, massive company. We were saying that HDP is the greener option. No, it's not. Well, this can be recycled. No, it can't. And I had this argument and actually went to a company called Phosplus and said, what's going on? This is reusable and recyclable. No, it's not, because that and sandwich packs will actually split the blue bag that the waste is collected in. Gentlemen, ladies and gentlemen, that's what we're up against. The experts not understanding that if you change the poly bag to nylon, we're home and dry. But anyway, thank you for your time.